Welcome back, everyone. So we're going to do some structural repairs, and I thought I would discuss the scope of what I'm going to be doing in this video, and we're going to take a look at some other head scratchers before we dive into that. So a little background on this house. It was built by a professional builder in between the winter and fall of 1954. It was sold to its original owners in November, exactly 66 years ago this month. And it's actually held up pretty well. Very, very minimal water damage, and I do mean minimal. The only part of this house that had any real rot or any water damage is right there. And I fixed the cause of the water damage in a previous video. I did it over the summer. And I had to make sure before I start repairing the water damaged wood, I need to make sure that fix was going to hold up, and so far it has been. I've had no water intrusion since July. So, but before I talk about that, I want to talk about a few other things that kind of make me kind of scratch my head here. And that has to do with the way this house was framed. So the lumber is exact 2x8 lumber, as was common back then. Nowadays they're much smaller than that. Well, they're a little bit smaller than that. But what I found intriguing is if you look up into the joist bay, you can see the ends of the opposing joists. And in some cases, it looks like they took the floor joists, stuck them in between two trees, and cracked them in half before they laid them in place. Like, some of them are cleanly cut, but they didn't cleanly cut everything. It's like they just cut just enough to break. Here's a good example. They cut here, you can see they cut that, and they just snapped it off. And you look, here's another one. You can see a clean cut here, but they cut just enough, and then they just snapped it in half. There's a few more of those. I found that really odd. Well, why do they do that? I mean, I guess, alright, you picture, this one's cleanly cut. You picture the time frame in which this house was built, and there was a housing boom, so maybe they were just taking shortcuts, I guess. I don't know. Here's another one. The sawmill that cut these joists didn't cut them exactly the same. There's a doubled up one here. So, here it is. So you look at this. Okay, and you're thinking, well, maybe it shrunk at a different rate. The floor above my head is a hardwood floor. The whole house has hardwood floors, and they are level. They're level. They're not bumpy. But check this out. This joist is a good maybe about a quarter to a half inch narrower than the one next to it. And they're both touching the subfloor the way they should be. But oddly enough, it just kind of makes you wonder what the hell was going on there. But this is even interestinger. So they both go into that bay right there, where they hit the rim joist. And if there was any discrepancy in height, you would have, severely buckled floors. I found that strange. Here's another thing I found. So if you look right here. So this is the wire for the electric stove. It's original. And look at this, there's a little bit of paint on there. See that? That is a kind of like almost like a peach. Looks like a flat peach colored paint. And you'll notice it's up here too. So based on that, you can draw the conclusion that before the hardwood flooring went in, they actually had painted the entire house. So they painted the house, installed and painted the trim, and then they laid the hardwood floors and the underlayment, which is underlayment in the kitchen and bathroom, because those have a asbestos vinyl tile floor in them, or what do they call that? Yeah, I think yeah, that's what it is. Anyway, but they painted the house before. This is actually the original color for the living room and closet, so which is above my head. And there's a few spots where you can see some paint that had dripped through, because again, the flooring went in last. I've never built the house before, so I didn't really, Okay, so now what you've all been waiting for, structural repairs and what my plans are. So I've talked about this in previous videos. I've finally started buying things and drawing it out of my head and coming up with a plan of action. So this is the trouble spot right here. This is really where all the damage occurred. So for years, water had been pouring off the edge of this. This is the front step. Front door's right here. Water had been pouring off the edges because there was nothing to prevent that from happening. When they this is a good head scratcher here too. What they did is they did all the framing for the whole house. They actually built the house. They had to have. So they had built the house, and then the last thing they did was they poured in this step here. So if you go upstairs, if you go right up here, right above my head here, they had used the walls themselves as the forms. So the walls and the floor joists were used as forms when they poured this. In fact, there were planks of wood right up, nailed into position with they probably had like a paper or tarp or something to keep the concrete from seeping through. But they literally poured this in place, but they poured it around a finished beadboard wall, which is unusual and not the right way to do it. But that's what they did. I mean, it lasted all these years, but it became a very serious repair in the end. So the result of all that water for 60-odd years pouring in, it rotted out the sill. In fact, there's nothing for a sill, probably about at least maybe a good 2 feet in. There's really nothing there for support to speak of. And I've checked it out with an endoscope, and yeah, it's pretty bad. It was basically eaten by ants and water damage, and I mean, it looks good from here, but you look at it from the other side. So, also, these tripled up floor joists are being supported by that wooden block. That's it. There's nothing else there to speak of, and that's just temporary so that the floor won't collapse. I didn't realize how badly damaged it was until I started pulling things apart to rebuild the entire entryway. And by the way, the cure that I came up with is I actually put in, actually used some OSB, and I used asphalt flashing tape, and I created a new wall, put in new walls all around, and I used mortar to create a curb around the entire perimeter of this slab, which I then, once that cured, I I coated it with a masonry waterproofer, which is a paint on. I actually used Crown Seal for chimneys, and I put a couple coatings of that on the entire repair. Once that cured, I painted the steps after acid etching them. So I'm pretty confident that it'll last for a good while. I'll probably have to go back in there and fix it again, but we'll see what happens. So I've already replaced this joist, which was totally rotted, and so that is ready to be nailed in. So once I start replacing these, that can be toe nailed in to the new joists on either side. So here's what the plan is. Normally, when you're replacing a joist or you're repairing one, you can just sister it with another joist. Because I have them tripled up here, and because of how, number one, they're tripled up, so there's no room really where the support is needed. There's no room to put in a sister joist. That just isn't going to happen. But the other thing is, I would have to cut out all three of these at once and replace them with three new ones. They're really, because this span is just over 6 inches wide, I would have to come up with another means of support for the floor above me to do all that. The other thing is, I would have to disturb and remove a section of my my return line. Or is that my supply? That's the return for the ductwork. So I'd have to take this whole section out, which I really don't want to do. But there's a silver lining here. Here's the deal. There's no weight above my head. This tripled beam is only built this way because it supports half the load for the front entryway. Okay, with me so far? Good. So because of that, there's not a lot going on up here. So I went out and I ordered a couple of house jacks or adjustable lally columns. And what I'm going to do is I'm going to take 2 lally columns. I'm going to put one right here to support this while I'm doing the work. And I'm going to put one right about here. And that's going to support, or however far back I decide to cut my joists, that's going to support the load for sure. And we're going to crank it up just to take the load off the anything that is sitting on. But I'm not going to stop there. What I'm then going to do, and I've talked to a contractor about this, and he agreed. He said this is how you're going to want to fix this. Based on the circumstances, based on what, I mean, it's not like this is holding up the house. Now that sucker right there, that's carrying all the weight. This, and the way this house is built, the exterior walls support the entire load of the roof. There is nothing in the middle supporting the load of the roof. It's a single floor house, so it's very, I guess I'd say efficiently built, so to speak. But yeah, anyway, so what we're going to do is I'm going to rebuild this section from this side. First thing I'm going to do, I'm going to cut probably about this far out of this. Yeah, we're gonna cut a good section out. Probably, yeah, I'm gonna go this far with it, maybe. See, we're gonna basically splice in new wood to this old beam, but we don't want our splices in line. We want to stagger them, so that way the load can be evenly distributed between the splices. Now, I don't. This one looks good from this angle. You look at it, wow, there's no rot. What are you talking about? The reality is, it's rotted pretty bad. It just doesn't look like it. But trust me, it's gonzos. At least probably a good inch or two into from where the band joist or the rim joist comes in. There's about an inch or so of rot. It's got to be cut out. Anywho, we're going to cut this out about right there. Pull it out. I'm going to run my Sawzall up in the top here. I'm going to cut all the nails that are going into the subfloor in the hardwood floor. I'm going to cut all those nails. I'm going to oh yes, this is important too. I'm going to relocate the water service line. I'm going to have to cut this out, and we're going to put some PEX tubing temporarily and just, do whatever we have to make that work. But we're going to get it out of the way, and maybe what I'll do is I'll run the PEX maybe along here, get it like way out of the work zone, and then when it's all said and done, I'll piece it back together with some collars and solder joints. Anywho, so we're going to cut that. Okay, you with me so far? Pull it out, then I'm going to go down to the next one. The next one's going to get cut probably somewhere closer to here. There's a mark that my contractor put right there. That's where he said he'd cut it there. And then we're going to do that. And the next one, we're going to cut it maybe over here. But the line, the splices will never be in line with each other. They'll be staggered about. As far as reassembly goes, here's the plan. I'm going to use construction adhesive. They actually make a structural adhesive for this application. I'm going to do some research as to which one is the best one. And the new lumber will be glued and screwed to the old lumber so that we have a nice sandwich, or basically a pseudo laminated beam going on. So these are the Headlock framing screws. Replaces a 3/8 lag screw. These are 6 inches long. They come in up to, I believe, 8 inches long. You don't even need a pre-drill. They're designed to thread right into the beam or the joist or whatever you're working on. And they really do provide some major clamping force. They're also good for shear strength. So the problem with using screws, like typical constructions or like drywall screws, for example, they're very brittle and they cannot stand cyclical loading. That's what these are good for. In fact, these should be able to be bent without cracking or breaking, much like a nail. But these, you can see they're demonstrating them as being used for a deck. So these you can actually screw a deck joist into position. You don't build a deck this way, you use joist hangers, but I'll just pretend I didn't see that. But yeah, these just screw right in. They're very, very strong. And they come in packages of a 12-pack. So this is what I use. This is what I'll be using. I'm going to use one like maybe every couple inches. I'll probably have to buy more of these things, but they aren't cheap. They don't come cheap. But where these come in handy is, for example, I could nail the joists together, but I'd rather have something long enough that I can kind of draw them all together at once. A nail is going to be, I could probably get through 2 of them, but beyond that, it's not going to happen. But not only that, nails, they can work loose as the wood dries and shrinks. So these are an option. And Headlock structural wood screw. But they're corrosion resistant. Decks, fences, headers, cabinets, islands, and more. So replaces a 3/8 lag. Refers to comparison of lateral shear design values for the Headlock as shown. So always consult your local code and books. And, they may not allow these. Some do, some don't. So anyway, that's kind of the long and short of it. And that, my friends, is how we're gonna fix this. As for the as for the sill, I'm gonna show you what I got going there. So I picked one of these up. This is an 8-foot 4x6. It is exactly the same dimensions as the existing sill. It's also pressure treated. The old sill was not pressure treated, but it was old growth lumber, so it held up pretty well, I have to say. This stuff here, this was like $14, that's all. Not very expensive. And in COVID times, I'm lucky I could find this. But this is exactly the same dimensions as the existing sill, so when I cut out the bad section, probably about a foot or two, foot or a foot and a half maybe, slide this in there. And, probably throw some adhesive or something. I don't know what we'll do for that, but we'll throw it in, and that's where the beam is going to rest on. So we're going to rebuild. That beam will be completely rebuilt. We're going to have to do the same thing over here, but not as bad. This one we're going to have to take our Sawzall. We're going to have to cut these nails here. Zing. We're going to probably take good, I don't know. I'm not going to take as much off. I'm not going to have to. These aren't that bad. This middle one did start rotting out, but it's not that punky. It's still holding some weight. So, and the one over here on the inside here, it's perfectly fine. What I will have to do is I'm going to have to figure out a way to cut out a couple inches of that sill, or maybe the whole section maybe, and slide some new lumber down in there just to shore it up. Because the end of the sill is gone. There's nothing there. Absolutely nothing to speak of. So we're going to have to do some demolition. What's unique about this house is that the front wall is a brick veneer, so I have no way of getting in there, like from the other side, without popping out bricks, which I'm not doing that. No freaking way. That might be the easier way to do it, is to, if you're going to do sill work on a brick house, is to actually cut bricks out. I don't want to do that. So I'm going to find a way to do it without cutting any bricks out. Okay, but we're not done. We aren't done. So I said this one here isn't really supporting much. Well, the story's a little bit different on this side. This one is not only supporting the other half of the entryway weight distribution, but it's also holding up the entire kitchen. That's right. The 9,000-pound French door refrigerator, the cabinetry, the stove, dishwasher, all being held high and proud by this beam. Now there's a telltale that there's a problem here. And funnily enough, this problem has nothing to do with what's going on over there. Because if you look carefully, this hasn't dropped at all. In fact, it's exactly where it's supposed to be. What's happening here is this beam has begun to sag, as any old house is going to do. In fact, my parents just bought themselves a new house that's only, 15 years old? And even it has some floor sag in a few spots that I've noticed. That's just what wooden houses do. And if you live in an area where houses are built on slabs, well, you'll never have to deal with this. But here in New England, most houses in New England are built like this. Wood does not maintain it when under a load. Even when it's not under a load, it tends to warp and it sags. So that's what we have going on here. So let me tell you what I'm seeing here. So this beam here. All right, because normally you would have the floor joists spanning the entire distance all the way to the carrying beam. This house is 26 feet wide, so these would typically span about 13 feet there to there, or more, because of the perimeter and shit. So because they put a staircase here, that was not possible. So they made up for that by tripling up these joists. These are, again, 2x8 joists. Those are tripled up, and they're supported by tripled up joists on either side, here and here. Not so bad, right? Well, again, when you have all that weight on those joists over a span of 60, 66, 67 years, eventually you're going to get some deflection. And you can see that with this telltale here. This is the original, this is a 2x3, it's a 2x3 actually, that was put in for the basement rail. And you can see that over those 66 years or so, it has begun to bend. This is not a load-bearing member. This is just to support the railing, but you can see just how much this beam has deflected. And I put a level on it, and you put the level here, and it drops just slightly. You put it over there, and it drops just slightly in the same direction. Well, in opposite direction, because it sags right about there. So what am I going to do to fix that? Oh, glad you never asked. The adjustable alley columns that I bought for this over here, to this repair work, I'm going to reuse them. permanently to re-support. I'm going to provide support for this junction here and that junction over there. Those lally columns are going to be there to provide moral support for the kitchen. And over time, I'm going to crank them just a little bit until the floors begin to... What the hell is he doing? Don't lick those walls. That's lead paint, buddy. What is he doing? What on earth? I wonder if he's licking my lead painted walls. Yeah, that paint right there, that's bona fide genuine lead. So I don't let my niece and nephew come down here when they visit, because I don't want them to grow up with problems. Isn't that right, Tommy? All right. What is he doing now? He's really into that wall. Maybe he is eating the lead. Hi, Oreo. You're on candid camera. So we are going to re-support the kitchen floor. I'm doing all of this in preparation because I'm going to be replacing the entire kitchen floor. The underlayment, which is, I believe, 7/8 plywood, as well as, of course, the tile that's on top of it. But I don't want to start installing new flooring and then have to readjust and level the floor later on after the fact. It just doesn't make any freaking sense. The one thing so what I'm probably going to do is I'm going to put the column there, but I'm also going to put it I'm going to put the other one right here, because this beam seems to be deflecting downward. I actually should order a third column and put it right there. That would probably make a little bit of sense. I tried something, on old houses like this, they didn't use joist hangers, because either they didn't exist or they cost too much. So what they would do is they would nail the joists in from this side here. Bang, bang, bang. And they used some pretty heavy-duty nails. I don't know what size they are, but they were pretty beefy nails. I thought I'd try something a little bit different. So I took some of these headlock fasteners, same fasteners I'm going to use when I repair that joist over there, and I put them in at a 45-degree angle. And these suckers, they can carry some serious weight. I just pre-drilled the holes and I ran them all the way in. These are 6-inch bolts, threaded bolts. They're like lag bolts. And I just ran them in, bang, 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 just to prevent those from ever shifting again, if they ever decide to do so. So what I did not do is address the elephant in the room. No, not me. What I'm referring to specifically is the lumber dimensions. All right, so you're thinking, okay, you're going to splice new wood into the old wood. How the hell are you going to do that when the new beams are going, or the joist, the new lumber, is not going to be the same width or height as the original? It's a good question. Well, like I said, these are exactly 2 inches by 8 inches. So they're thicker and beefier than a modern 2x8. Now, you can make up for the height difference. Let's say you're replacing an entire joist from one end to the next. You can go ahead and buy a modern 2x10, run it through a saw to exact 8 inches, an exact 8-inch height. You can do that. That's perfectly fine. But if you're going to be doing what I'm doing and you're going to be splicing new wood into old wood, it has to be the same, at least the same width. You can't make them thicker, obviously. Otherwise I would, but I can't. But that's where old-timey lumber mills come into play. So if you're in this situation like I'm in, and you don't want to replace the entire floor joist because there's no need to, and it's more work, and you're lazy, you can call up a lumber mill or a sawmill, and you can get custom lumber made to your specs. So I called up a company called Wilkins Lumber. They're out of Mount Vernon, New Hampshire. Give them a little plug. They've been in business since like the 1860s or something, and they've been in business a long time. And they still cut lumber on site from local trees to whatever the hell specs you want. If they can get a log big enough or whatever, they will do it for you. So they are going to sell me 4 2x8x6s so I can complete this project. And the fee isn't that much. It's a little more expensive than going to Home Depot, but it's better. It's local wood, it's better wood, and it's cut to the exact dimensions I need. So this way, when I'm laminating these beams, or laminating these joists, that's the term for layering them up, they're going to be the same thickness. So I won't have a misalignment between all three of them. Okay, does that make sense? Makes sense to me, so I'm going to roll with that. But that's what they do, and that's all they do. So I'm very happy about that. Now, the one thing I haven't considered is I'm not so sure that the wood I'm going to be buying will be kiln dried, so it's going to be subject to shrinkage over time. How much, I don't know, but hopefully not too much. So, and that is what I'm talking about. And this repair, by the way, is one of the major things. It's been one of the main sore points, one of those on the forefront of my mind since I bought the place, because I know it has to be done. I know it's going to be a lot of work, and if I hire somebody, it's going to be extremely costly. But I think I can handle this one with a little thought, a little bit of foresight and planning, and make sure that nobody's in the house when I start cutting the supports out. You don't want somebody walking across the floor when the floor joists aren't there. So that's a big deal. I also want to point this out. You can actually see, okay, apparently these beams aren't nailed together very well, because this is what's happening. You can see that this one here, these two right here, these are dropping. Yeah, a little bit. They're dropping just a wee bit. And that's because they're carrying all the weight. So, yeah, that's not fun. But that's what's happening here, and we're gonna fix this. We're gonna fix it. We're gonna fix it good, I hope. Relocating the electrical wiring temporarily is not a big deal. Those staples can be removed fairly easily. Not as easily as they should be, but I'm not worried about it. So we're going to take those staples out. We're going to just drop the wiring down. I already started some of that over here. And we're going to just move the wiring. While I'm in here, I'm going to go ahead and replace the wiring that goes from the panel to the 2 outlets over here. And then it goes up into a light switch. We're going to rip all this old crap out. Just get it done, and put new grounded wire in its place. At least that's the plan. It'll all be part of the same project, I think, and it should be pretty easy to do. Let's see if we can get a better look at this damage. Look at that. Yeah, it's pretty bad. I have seen worse. Believe me, I have seen worse. This house was actually in the best condition structurally than most of the houses that I looked at before I bought this one. This one did not have any major structural defects. The inspector said, yeah, it's a solid house. with that exception, and that's all fixable stuff. But the foundation was solid, no cracks. Word of caution: if you're in the market for a house and it has a block foundation, be wary of that, because block foundations, not that, I mean, they're not bad, but they're not great, because they're subject to ground movement and shifting loads. They do not have the same shear strength that a poured foundation will have. I mean, they just don't have it. I mean, they're not bad. I mean, if the foundation's not cracked or anything, but if you start seeing step cracks in the foundation, that could be a sign of ground movement. And these poured foundations can handle it pretty well, where a block foundation, not so much. I have foundation cracks. They're hairline cracks, but they're just part of settling, and it's okay because there's rebar. There's steel bars embedded in these walls, so that, you know, the wall's not going to just crumble. But I've got a hairline crack right where that window is, and that's pretty typical. You're going to see that in a concrete wall. It happens. I mean, again, this house is 67 years old, so you're going to get that. And on the outside, you can see a hairline crack right near this window, I think. Yeah, I don't see it here, but there is a crack visible on the exterior on that window. And you've got, this is normal. We're going to take care of this when I start sealing the basement walls with, I'm going to either do a spray foam insulation, or I'm going to do something a little bit cheaper. But you can see this white stuff, that's efflorescence. That's just lime and salt coming through the wall. It's just soaking through the wall as the ground gets wet. That is pretty common, pretty normal. You know, this is kind of what you want to see. But I looked at one house that had a concrete block foundation, or a cement unit foundation, and there were step cracks everywhere. In fact, one section of the foundation was crumbling. And I said, you know what? No, this isn't the one for me. One of the things I did when I started looking at houses, and I recommend you guys do this too, look at the basement first. Look at the wiring, look at the plumbing, look at the foundation, look at the floor joists. If all that stuff is good, you can fix everything else. If the foundation is crumbling, it's fixable, yes, but it's going to cost you. And if you've got leaking plumbing everywhere, then that's going to cost you too. This house definitely still has plumbing issues, but they're just not serious enough for me to warrant fixing them right now. But after I finish this structural deal, I'm going to start doing some valves. I've already done a couple of these quarter turn ball valves, but these valves here, these are original, and they're garbage. If I touch this valve, turn it just even a slight amount, it will leak for about a week before it corrodes shut again. But these valves are no good. They are no good. They've got to go. So I'm going to start cutting these suckers out and putting in new ones and patch the piping up a little bit. I've already replaced one in the, I think I did that on video, where I showed you guys what I did. But the valve up there in the shower had to be replaced. And I've got a cluster of them over here, and these have got to go. But quarter turn ball valves will solve this problem. It's actually wet, a little bit moist. You see these little crystals. Well, maybe not wet, but it's seeping enough to cause those little crystals to form. This one too. These are garbage. If you have, there's a dishwasher running. If you have an old house like this, or you're renting an apartment like this, that's as old as this, don't touch the valves, because if you do, they will leak, guaranteed. These are only really good for an emergency where, let's say, a pipe burst in the kitchen. I need to shut off that one section. You know, that's what these are for. But you start fiddling with these valves, and you're gonna be sorry. I made that mistake once in my parents' house. I'm like, Dad, I turned this valve and now it won't stop leaking. Like, you son of a bitch. You had to replace the valve. So that's the harsh reality of plumbing. So quarter turn ball valves, those are usually okay. But these globe valves, oh my God. So what happens is all the seals dry up over time. You know, after about 10, 15, 20 years, forget it. These are 60 years old. So they're donezo. Totally done. You can't even be rebuilt, they're so bad. But yeah, the packing seals, they're garbage. Garbage. So what we'll do is we'll just basically cut them out, put in a couple pieces of new copper, and solder them in. Done. I mean, I'm not using these right here. These are push fit connectors. I don't like using these. I used them here because they work, and this was just a quick solution. I didn't have to buy a torch or anything, but that's just to feed the fridge. I did that in PEX. But anyway, yeah, everything looks pretty good. It looks kind of wet. Is that wet? No. No, there's nothing there. Yeah, there's a seam for the sill. Oh, it's phone lines. They cut out all the phone lines. I don't need phone lines. Why do I have those? Let's rip them out. Yeah, right now we're above the kitchen. No, this is where the dishwasher is because I screwed this floor in. You can see where the screws are. Dishwasher's right above my head. But this stuff here, this stuff is loose. This is mortar, and they put this stuff. They just troweled it on for reasons I don't quite understand. Maybe to keep bugs out, but they troweled it up against the sill. Anyway, well, that's going to be it for now. So now you understand what I'm trying to do, what I'll hopefully be accomplishing in the next couple of weeks once I get my lumber shipped, and or once it starts getting cut, because they're backed up right now. But oh yeah, I wanted to show you the headlock bolts. I don't know why I didn't do that earlier.